In an age of data-driven decision-making, statistics have become a central part of our understanding of the world. Whether in politics, media, business, or everyday conversations, numbers are often presented as objective, neutral facts that reveal undeniable truths. However, statistics are not always as straightforward as they seem. While numbers can provide valuable insights, they can also be manipulated, misrepresented, or taken out of context to create misleading narratives. The phrase "numbers don't lie" is often thrown around to suggest that statistics are irrefutable, but the reality is more complicated. Statistics can be manipulated in various ways, through selective data, misleading visualizations, or inappropriate comparisons, to serve specific agendas or influence public opinion. In fact, one of the greatest dangers of statistics is that their apparent objectivity can make them seem more trustworthy than they actually are. When we see a percentage or a chart, we tend to assume that the data speaks for itself, without questioning how it was collected or presented. Statistics are powerful because they provide a sense of authority and precision. People tend to trust numbers more than words, making it easier to accept statistical claims without digging deeper. However, numbers can be cherry-picked, manipulated, or distorted to fit a narrative. When used unethically, statistics can be a tool for misinformation, steering individuals toward conclusions that aren't entirely supported by the data. This video will explore the various ways statistics can be manipulated, the psychological reasons why we tend to trust numbers so readily, and real-world examples of how misleading statistics have shaped public opinion and policy. By the end of this discussion, you'll have the tools to recognize when statistics are being used to deceive and how to approach data more critically. Before diving into the techniques used to manipulate statistics, it's important to understand why we are so inclined to trust numbers in the first place. The human brain is wired to process numbers in a way that gives them inherent authority. When presented with a statistic, we often accept it without questioning its origin or validity, a phenomenon known as the appeal to numbers. The illusion of precision. One of the key reasons why we trust statistics is that they give the illusion of precision and objectivity. Numbers seem exact and unambiguous, which contrasts with the subjective nature of language. For example, if someone says crime is on the rise, we might ask for evidence. But if they say crime has increased by 25% this year, the specificity of the number makes the claim seem more credible, even if we don't know where the figure comes from or what it really means. This illusion of precision leads us to believe that numbers represent an objective truth, even when they may be cherry-picked, misrepresented, or based on faulty data collection methods. Statistical anchoring. Another psychological factor that influences how we interpret numbers is anchoring, the cognitive bias where people rely heavily on the first piece of information they encounter, the anchor, when making decisions. When a statistic is presented early in a conversation or debate, it becomes the reference point for evaluating all subsequent information. For example, if a news article states that unemployment is at 10%, that number becomes the anchor in your mind, even if you later learn that it only reflects a temporary spike in unemployment due to a specific event. Once a number is established as the anchor, it can distort how you interpret other statistics, leading you to overestimate or underestimate trends based on the initial figure. The authority of experts. People are also more likely to trust statistics when they are presented by experts or authoritative sources. If a statistic comes from a government report, a major news outlet, or a well-known academic study, we tend to accept it as reliable without scrutinizing the underlying data. This trust in authority figures can be problematic when statistics are manipulated or misused by experts who have a vested interest in promoting a certain narrative. For example, politicians often use selective statistics to support their policy proposals, knowing that the public is unlikely to question the validity of the data when it comes from a seemingly reputable source. Now that we understand why people tend to trust numbers, let's explore the various ways in which statistics can be manipulated. These techniques range from subtle distortions to outright fabrications, but they all share the same goal: to mislead people into drawing inaccurate conclusions. Cherry-picking data. One of the most common ways to manipulate statistics is through cherry-picking, or selectively choosing data that supports a specific narrative while ignoring data that contradicts it. By focusing only on certain points in the data set, statisticians can create a misleading impression of the overall trend. Misleading averages. Another way statistics can be manipulated is through the use of misleading averages. There are several types of averages: mean, median, and mode, and choosing the one that best fits the narrative can significantly alter how the data is interpreted. For example, consider a company that wants to show that its employees are well paid. They might report the mean salary, which is the total of all salaries divided by the number of employees. However, if a few top executives are making millions while the majority of employees earn much less, the mean salary will be skewed upward, creating the impression that everyone is earning more than they actually are. In this case, reporting the median salary, the middle value when all salaries are listed in order, would provide a more accurate picture of what most employees earn. By choosing the average that best supports their argument, people can manipulate how the data is perceived without technically falsifying the numbers. Percentage increases without context. Percentages are a powerful way to communicate changes in data, but they can be highly misleading when taken out of context. A common tactic is to report a percentage increase or decrease without providing the base number, making the change seem more significant than it actually is. For example, a headline might claim that Company X's profits increased by 200% last quarter, which sounds impressive. However, if the company's initial profits were very small, say $1,000, a 200% increase would mean their profits only rose to $3,000, which is far less significant than the percentage suggests. Without context, percentages can be used to exaggerate or downplay trends, making them a convenient tool for those who want to manipulate public perception. Misleading visualizations. Statistics can also be manipulated through visual representations, such as graphs, charts, and infographics. The way data is displayed can influence how it is interpreted, even if the numbers themselves are accurate. Another visual trick is to omit data points that don't fit the narrative, such as cutting off the timeline before a downturn or excluding a category that shows a decline. These visual manipulations can create a misleading impression of the data, even if the numbers themselves are technically correct. Spurious correlations. Sometimes statistics are manipulated by presenting two unrelated data points as though they are connected, a technique known as spurious correlation. This involves suggesting a cause and effect relationship between two variables that are only coincidentally related. For example, a headline might claim that ice cream sales are linked to higher crime rates, citing statistics that show both increase during the summer months. While this correlation is true, it's misleading because both ice cream sales and crime increase due to warmer weather, not because one causes the other. Spurious correlations can be used to create false narratives, leading people to believe that one factor is responsible for another, when in reality there is no meaningful connection between them. To better understand how statistics are manipulated in practice, let's look at some real-world examples from politics, media, and business. These cases illustrate how numbers can be twisted to serve a particular agenda, often with significant consequences. Political polls are a common source of statistical manipulation, especially during election seasons. Pollsters may use selective sampling, leading questions, or biased weighting to produce results that favor one candidate or party over another. By manipulating the sampling methods or phrasing, pollsters can create results that appear to reflect public opinion, even though they don't accurately represent public sentiment. Corporate profits. Companies frequently manipulate statistics to present their financial performance in the best possible light. This is especially common in quarterly earnings reports, where businesses want to impress investors and shareholders. For example, a company might report a significant percentage increase in profits by comparing their current earnings to a particularly bad quarter from the previous year. By choosing a low baseline, they make the current quarter's performance look much better than it would if they had compared it to a more typical period. This tactic is known as earnings management, and while it's not illegal, It can mislead investors into thinking the company's financial health is stronger than it really is. Another tactic is to emphasize non-GAAP, generally accepted accounting principles metrics, which allow companies to exclude certain expenses or losses from their earnings reports. By presenting these adjusted figures instead of GAAP-compliant figures, companies can create the impression that their performance is better than it actually is, even though they are leaving out important information. Health and medical research. In the realm of health and medical research, statistics are often used to promote products or treatments, and manipulation can occur at multiple stages of the research process. One common tactic is publication bias, where only positive results from studies are published, while negative or inconclusive results are ignored. For example, a pharmaceutical company might fund multiple studies on a new drug, and even if several of those studies show no benefit, only the positive results will be published. This creates the impression that the drug is highly effective, even though the overall body of research might suggest otherwise. Additionally, health statistics are often presented without proper context, making treatments or products seem more effective than they really are. For instance, a new medication might be promoted as reducing the risk of heart attack by 50%, but if the baseline risk of heart attack is only 2%, then the drug reduces the risk to 1%. While technically accurate, the way the statistic is framed makes the drug appear much more impactful than it really is. In addition to manipulating the numbers themselves, the way statistics are visually represented can significantly influence how they are interpreted. Graphs, charts, and infographics are powerful tools for communicating data, but they can also be used to distort the truth, often in subtle ways. Misleading scales. One of the most common techniques used to manipulate visual data is adjusting the scale of a graph or chart. By altering the range of values on the axes, statisticians can exaggerate or minimize trends, even if the underlying data doesn't support such an interpretation. For example, imagine a line graph showing a small increase in sales over time. By narrowing the y-axis to show only a small range of values, the line will appear to rise sharply, giving the impression of rapid growth. Conversely, if the y-axis covers a very wide range, the same increase might look almost flat, minimizing the apparent growth. This technique is often used in political campaigns, where candidates want to either exaggerate their successes or downplay their opponent's achievements. By manipulating the visual scale, they can make modest improvements look dramatic, or make significant changes seem insignificant. Truncated y-axis. Another common tactic is using a truncated y-axis, where the axis starts at a number other than 0. This can create a distorted view of the data, making small differences look much larger than they really are. For example, a bar chart comparing the incomes of two groups might start the y-axis at $40,000 instead of 0. If one group earns $50,000 and the other earns $60,000, the bars will look dramatically different, even though the actual difference in income is only $10,000. By cutting off the lower part of the chart, the difference between the two groups appears much more significant than it would if the full range of incomes were shown. Omitting data. Sometimes charts and graphs are manipulated by omitting relevant data. This is particularly common in trend graphs, where certain data points are left out to make a trend look more consistent than it actually is. For example, a graph showing a company's revenue over time might omit the years in which the company experienced significant losses, focusing only on the years where revenue grew. This creates the impression of steady growth, even though the company may have struggled during certain periods. By selectively omitting data, the presenter can create a more favorable narrative that doesn't fully reflect the reality of the situation. Using pie charts incorrectly. Pie charts are a popular way to represent parts of a whole, but they are often misused in ways that can mislead the viewer. One common mistake is using pie charts to compare values that don't add up to a meaningful whole, or using them in situations where the differences between categories are too small to be easily distinguished. For example, a pie chart might be used to show the percentage of different political parties in a poll. But if the percentages are very close to one another, the visual differences between the slices can be hard to interpret accurately. In such cases, a bar chart or line graph would provide a clearer representation of the data. Another misleading tactic is using 3D pie charts, which can distort the perception of the relative sizes of the slices. In a 3D pie chart, the slices that are closer to the front appear larger than those in the back, even if the actual percentages are the same. This creates a visual bias that can influence how the viewer interprets the data. Even when statistics are presented accurately, people's confirmation bias can influence how they interpret the data. Confirmation bias is the tendency to seek out, interpret, and remember information in a way that confirms one's pre-existing beliefs or opinions. This bias can cause people to ignore or dismiss statistics that contradict their views, while giving undue weight to data that supports their perspective. Selective interpretation. Confirmation bias plays a major role in how we interpret statistics, especially when the data relates to controversial or emotionally charged issues. For example, in a political debate, individuals might focus on the statistics that align with their preferred candidate's platform, while dismissing or downplaying data that contradicts their views. This selective interpretation allows people to reinforce their existing beliefs, even when the evidence doesn't fully support them. As a result, two people can look at the same set of statistics and come away with completely different conclusions, depending on how they process the information through the lens of their biases. The backfire effect. In some cases, presenting people with statistics that contradict their beliefs can trigger the backfire effect, where individuals become even more entrenched in their views when confronted with conflicting evidence. Instead of changing their minds, they may double down on their original beliefs, interpreting the data in a way that supports their position. The backfire effect highlights the challenges of using statistics to change people's minds, especially when the data conflicts with deeply held beliefs or ideologies. Given the many ways that statistics can be manipulated, it's important to develop strategies for recognizing and resisting these tactics. By approaching statistics with a critical eye, we can avoid being misled and make more informed decisions. Ask critical questions. When confronted with statistics, it's important to ask critical questions about how the data was collected, analyzed, and presented. Some key questions to consider include: who collected the data? Consider whether the source of the data has a vested interest in promoting a particular narrative. For example, a company might present data that supports their product, but that data might be biased if the company funded the research. How was the data collected? Look at the methodology used to gather the data. Were there any potential sources of bias in the sampling process? Was the sample size large enough to draw meaningful conclusions? What is the baseline? When presented with percentage increases or decreases, ask about the baseline numbers. A percentage without context can be misleading if you don't know what the original value was. For example, a 50% increase could sound significant, but if the baseline was small, the change may not be as dramatic as it seems. What type of average is being used? As we discussed earlier, the mean, median, and mode can all tell different stories. Be sure to understand which type of average is being presented and whether it accurately represents the data. Is there any data missing? Consider whether the information you're being shown tells the whole story. Are there data points or categories that have been left out? Has the timeline been truncated to exaggerate a trend? By asking these critical questions, you can start to see through statistical manipulations and get a clearer sense of what the data is actually showing. Beware of misleading visuals. When interpreting charts and graphs, pay close attention to how the data is being presented. Here are a few things to look out for. Check the scales. If the scale of a graph seems exaggerated or misleading, it's worth questioning whether the trend is being accurately represented. Look at the range of values on the axis and consider whether a different scale would provide a more honest depiction of the data. Look for omitted data. If a chart seems to be missing important context, such as data points that don't fit the narrative, it's a sign that the presenter may be selectively choosing which information to show. Always ask whether you're seeing the full picture. Be cautious with pie charts. As mentioned earlier, pie charts can distort data, especially when 3D effects are used, or when the differences between categories are small. Consider whether a different type of visualization would provide a clearer comparison. Don't rely on headlines alone. Many people get their information from headlines, especially when it comes to statistics. However, headlines are often designed to grab attention, not to provide nuanced information. Be wary of sensationalist headlines that report dramatic percentage increases or alarming figures without offering context. Whenever possible, go beyond the headline and read the full article or report to understand how the statistics were derived and what the numbers actually mean. Seek out multiple sources. One of the best ways to avoid being misled by manipulated statistics is to seek out multiple sources of information. Different organizations and experts may interpret data differently, and by comparing their interpretations, you can get a better sense of what the numbers actually indicate. For example, if a statistic about unemployment is being reported in a way that seems questionable, look for data from multiple sources, including government reports, academic studies, and independent analyses. By considering a range of perspectives, you can avoid relying too heavily on one potentially biased source. Understand the difference between correlation and causation. As we discussed earlier, spurious correlations are a common way to manipulate statistics. Just because two variables are correlated does not mean that one causes the other. Be cautious when you see statistics that suggest a cause and effect relationship without clear evidence to back it up. For example, if a news report claims that increased screen time is leading to a rise in mental health issues, it's important to ask whether other factors might be at play. Is screen time the cause? Or is it simply correlated with other lifestyle changes that could be affecting mental health? By being aware of the difference between correlation and causation, you can avoid being swayed by misleading interpretations of data. Develop critical thinking skills. Finally, developing strong critical thinking skills is key to resisting manipulation through statistics. Critical thinking involves questioning assumptions, evaluating evidence, and considering alternative explanations. When faced with a statistical claim, take a moment to reflect on whether the data supports the conclusion being presented, or whether there might be other ways to interpret the information. Remember that statistics are not neutral. They are always presented within a context, and that context can be shaped to influence how we interpret the numbers. By thinking critically about the data you encounter, you can avoid falling into the trap of trusting numbers without questioning their validity. In a world where data is increasingly used to inform decisions, shape public opinion, and guide policy, it's more important than ever to be statistically literate. While numbers can provide valuable insights, they are not immune to manipulation. By understanding the various ways statistics can be distorted, we can become more discerning consumers of information. Manipulating statistics is not always about lying or presenting false data. More often, it's about presenting real data in a way that tells a specific story. Whether it's through selective sampling, misleading averages, or biased visualizations, those who present statistics can use them to push a particular narrative. Without proper scrutiny, we are all susceptible to being misled by numbers that seem credible but are actually deceptive. However, by developing a healthy skepticism towards statistics, asking critical questions, and seeking out multiple sources of information, we can guard ourselves against manipulation. Recognizing the signs of statistical distortion and understanding how data is collected and presented are essential skills in today's data-driven world. Ultimately, statistical literacy is about more than just understanding numbers. It's about thinking critically, questioning assumptions, and being aware of the broader context in which statistics are used. By fostering these skills, we can ensure that we are making informed decisions based on accurate and reliable data, rather than being swayed by numbers that are designed to deceive.
Remember to like and subscribe for more video content. Sapiens quae vigilat.